Hello everyone, we are going to be solving daily Leetcode problem with 2411 smallest subarrays with maximum bitwise OR. This was a problem given on 29th Tuesday, 29 July, that was Tuesday, right? So before starting this problem, we shall have a small motivational quote. We suffer often in imagination than in reality, imagining worst case scenarios, regretting the past, and fearing the future. Rather than from actual events, our mind creates problems that doesn't even exist, making us anxious, stressed, and unhappy long before real things happen. In truth, many things we worry about never occur, and even when challenges arise, we often handle them better than when we are feared. Right? So, the lesson that we should learn here is never imagine troubles. uh, don't let imagined troubles steal your peace. Focus on what's at hand and deal with the problems as they come, right? So we always uh, there is always a saying that stay in the present moment rather than thinking about the future nor the present, right? So that's what this quote really tries to say. Okay, so let's understand this problem statement. You are given a zero indexed array nums of length n consisting of non-negative integers for each index I from 0 to n minus 1. You must determine the size of maximum sized non-empty subarrays of nums starting from I inclusive of the specific index such that maximum possible bitwise OR. In other words, B of ij be the bitwise OR of the subarray I to j. You need to find the smallest subarray starting at I such that bitwise OR of this subarray is equal to B of I comma k. Bitwise OR of an is OR of all its numbers. Okay. Return an integer array answers of size and where answers of I is the length of minimum size subarray starting at I with maximum bitwise OR. So we need to understand few things from this problem. So let us go through this example one to understand this problem better. So let's say we are given with nums 1 0 2 1 3. So the maximum possible OR value that can be achieved with this array is 3. That is an OR operation between either this one or all of these. So in order to achieve 3 starting at index 1, what is the value? So we need to go through all these 3 subarrays, right? So this is the subarray that forms. So the length of the subarray is the return value at the specific index. Similarly here, this is the subarray. So this is the answer. And here it's 2, and here it's again 2, and this one it's just the specific digit. Okay, so understanding that, let's go to the example 2. Nums uh, nums at let's say we are given with nums 1 comma 2. uh, what is the output? The bitwise or the maximum value that we need to get for this value is 0 1 and 1 0. This is again 3 starting at the shortest array that yields the maximum bitwise OR is of length 2, while starting at 1 the shortest array that yields the bitwise OR is of length 1, therefore we return 1, right? So understanding this, we should quickly know that our approach should, with intuition, pure intuition, I am just taking the example one where we had uh, 10213 as nums. So uh, we are expected to return answer which at each point we are, so at each index it's the subarray, right? So this answer is the subarray. So 102, these are the digits, and here 0 1 2. It's the length of the subarray that we are forming, right? So we clearly understand that the specific digit should be traversed in the right side direction only, right? So uh, this is kind of a statement which might trick us, but eventually we will be approaching this problem iterating from right to left. The reason being, we are firstly finding a specific digit which has a maximum or value, and we consider if we need to include it or no, right, to form the minimum length of a subarray to form the maximum or, right. Okay, so I will go about the approach that we are going to take to solve this problem. So we are going to traverse from right to left as discussed. So let's say we iterate from right to left on the nums array, left, and we also keep track of bits, that is we can have few variable declarations such as length and last seen max value. This would be an array of 30 values. For each number of at a specific index, we uh, prepare this 30 index bitwise value so that we compute the OR of it, and results, that is the value that we are going to length at index, that is the output that we are going to return. So now since we are going to iterate from right to left, so let's say we have a for loop starting at length I is equals to length minus 1, and we iterate I greater than 0, I minus minus, and we go through each of the bit. So for each bit I is equals to 0 to 30, we check if num set I and left shift of bit is greater than 0. So what's happening here basically is we loop through each bit position to see if the bit represents nums of I, right? So that's the whole idea, and we also have this results of I, which takes about, I will, so once we do if uh, nums of I and one left shift of bit is greater than 0, and we say last seen value of bit is equals to I, that is the specific digit in the decimal place that we are looking at, and the result that we get for would be result at I or last seen bit minus I plus 1. So I would be the uh, last maximum value of XOR that we can extend, or the result value that we would compute of the specific bit, right? So either the specific digit satisfies, or we need to extend it till the last seen bit, which has the maximum XOR value through this if loop that we are running, right? So uh, that would be our whole logic. I think this if loop is a piece where we need to understand, and also this is a specific piece where we need to understand. So I will explain this piece of if loop a bit more in in a easy way to digest, right? So let's take an example. Say num set I is equals to 10 and also a bit of 3. This can be represented as 1010, and this can be represented as 0 1 1 and 0. So with the if loop that we had, where we are checking num set I and one left shift of the specific bit, so this will change to uh, 0. This will change to 100. That is, this will change the bit to this place, that is left shift of the bit, and this one will already be 1010, and this will give us a maximum bit value such that 1000, or this will be 1100, right? uh okay, hold on, let me redo this. So consider this example where we have num set I is equals to uh, num set I is equals to 10, and we perform this if loop which we were discussing as a core piece of logic, just to see what is the maximum XOR value that can be obtained at a specific index. So this will be equals to num set I and one left shift of the bit. So once we do this, we set the, if it is, if this value is, all of this value is greater than 0, then we set the last largest seen bit at the specific index is equals to I, right? So this is the maximum value that we are required to iterate or create the subarray for a specific index. So now we are understanding what this piece of if loop is doing, right? So, and this is an AND operation, and this is a left shift of a bit operation, right? So let's consider this as an example where num set I is equals to 10. The binary representation of 10 is equals to 1011, 1010, and a bit of 3. So if we have a bit of 3 bits, let's say something like this, then left shift of this bit would be 100, right? So this would give us an AND operation with 1010 and 100. This will give us a value 100 and 1010, which is equals to a maximum value of 8 or greater than 0, right? So that we store it in the last scene. So I hope that makes sense. With that being said, I will go to the Leetcode editor and start adding the code up to solve this problem. Okay, so this should be our solution. So let's try submitting the solution. The only piece of logic that we need to think about is this piece where we are calculating the bitwise left shift and also an and operation with the specific value at nums index. This would give us um, a maximum value that can be reached even before the index or the result at I. So, right? So, just take a quick pause and think about how this logic works, and this solution should look easy, right? The two logical issues that I see in this problem is one with respect to the evaluation of this AND statement, that is, and also one value being reduced that I identify here, right? So these two values, which should be this should be which should be 3, right? So let me submit this. This should submit the solution. While this gets executed, the time and space complexity of the solution is O of n, as we are iterating through n nums length, and also this is a constant execution of 30 bits, and space complexity would be O of n as well, because we are having to store this result array, right? Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.